Alright, this video is about MRAM, which stands for midpoint, and it is another way to estimate area. We have LRAM, which uses the left-handed rectangular approximation method. We have RRAM, which is the right-handed rectangles, and then we have MRAM, which is midpoints. And it's probably often the best approximating method, but it's the least liked because the math is always a little bit harder to do, just because the numbers kind of end up being a little bit ugly. So in the last two videos, we were using the example from class where we had a parabola, and the parabola was y equals x squared, just like a very typical one. And we were finding the area under the curve from 1 to 4 is what we had picked. And we could pick different points. I'm just picking ones that are easy to do. And we were trying to find this area. And we were doing it, you'll have to watch the other videos, but we were doing it by splitting it up into these little rectangles. Well, we're going to do the same thing for the midpoint approximation method, except the rectangles are going to be a little bit trickier. So let's redraw this region. Let's zoom in and draw it a little bit bigger. We only need a first quadrant graph. We don't need all this extra space. So here's my first quadrant. And I'm going to draw it like this, a big y equals x squared. And I'm going to put, like, let's say here's 1, here's 2, here's 3, and here's 4. We're going to build 3 rectangles under the curve from 1 to 4 here in this space. And I'm going to do it using all the midpoints. So instead of using like 1 and 2 and 3 and 4, I'm going to use 1.5, 2.5, and 3.5. Those are your midpoints. So I'm going to go here to this first one, 1.5, and I'm going to put a dot on the curve right at 1.5. And then I'm going to go to 2.5 right here and put a dot on the curve. And at 3.5, the same story, put a dot on the curve. And essentially what I'm going to do is between 1 and 2, I'm going to draw a rectangle that goes straight through the middle of the midpoint, like this. So here's my first rectangle. Then I'm going to do the same thing. So let's zoom in a little bit here. Hopefully this doesn't make the video get all shaky. But see what I'm doing? See how I'm drawing the line straight through the midpoint? So the next rectangle, if this is 2.5, I'm going to draw a line that goes straight through 2.5 on the curve and down. And that'll be my next rectangle. And then the last rectangle, the same story. 3.5, I draw a line through the curve, straight down. And there's my third rectangle. And so now I got to add up length times width, length times width, length times width 3 times for 3 rectangles to get my answer. You can see why this is better than LRAM and RRAM. It's the best approximating method because you have these little gaps that are getting left out. You can see these little gaps right there. But you also have this overestimation on the outside. Kind of counterbalances and gives you a nice even answer. It won't be a perfect answer, but it's really good. So what I'm going to do is write area equals, and we're going to do the length times the width, so the dimensions of each of these rectangles. Notice that the width is still a width of 1. If you were to measure these, it's a width from 1 to 2, 2 to 3, 3 to 4. So this first rectangle here, let's change it to the color blue. The blue rectangle has a width of 1 and a length. Well, the height of this rectangle, remember I used 1.5, the midpoint. So if I put 1.5 into x squared, it's going to be 1.5 squared, length times width. Now let's add on the next rectangle. It has a width of 1, and then 2.5 was my midpoint, so it's going to be 2.5 squared when I plug it into this to figure out how tall is it. And then my next rectangle is at 3.5, but it has a width of 1, so plus 1 times 3.5 squared. And then these are the 3 rectangles, and all I got to do is, do the math. Basically, plug it into the calculator. And when you plug this in, you can double check me. It should be 20.75. And that's my best estimated area. To make it even better, chop the space up into 6 or 10 or 20 rectangles. It just gets harder every time you make more rectangles. You have to pick more midpoints. So you get a lot of decimals when you're doing this one. but it is a really good approximating method. Probably the best most of the time. And that's kind of how the MRAM, the midpoints, work.